Hello. So today I am going to present how I created the model, how I trained the model, and how I can see the differences in different training approaches for a model. What is the problem statement? We are required to build a model and train a model to predict the electrical energy output of a power plant. And this power plant uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. So uh, we we have data which basically consists of combination of temperature, pressure, humidity, and vacuum, and also the electrical energy output produced. Okay, and the electrical energy output produced is the target to be predicted. We have got less than 10,000 rows for it, but sufficient for us to train our model and see the variations of the data. So the approach which I used for this, since we are required to do a prediction, I use a linear regression approach for training the model. The tool I use for Azure AI, Machine Learning Studio. The outcome metrics is power output. The approach which I've been using is I use the same algorithm to run to train the model twice with below variations. In the first approach, I use the 10 times k-fold variation approach, whereas in the second time it was a standard validation approach. And then in the second time, so in the first time I use all the values of the features data. In the second time, what I did was I used the same value of ambient pressure and then most frequently use values of temperature. So I wanted to see what is the impact of pressure and temperature on the power output. So this is the approach one. So when this was set up in Azure AI ML Studio, what I did was, this is a task type regression being used. Target column is output energy, k-fold cross validation, number of cross validations was 3. And the entire data set which is provided, 10% of it was used for testing the data. Okay, this was the approach 1 or the run 1. And in the approach 2, again the task type was regression. The target column is P, and again, however, the validation type was automatic, and again the 10% of training data was used as test data. Okay. However, over here you see the data on pressure was basically used as a fixed value of 1012.16, and the temperature was set up to use the most frequent values. Once the model was run in both these approaches, here was a list of the output generated by the Azure Studio. So power output 2 is the one where I use the variations on the feature data. And also the and power output is the one where we use a k-fold validation approach. If you can see, what it signifies is that the temperature or the pressure did not have too much of impact on the power output, basically. Okay. If at all there are any variations, it is very, very negligible at this point of time. And there is as such no variation on the normalized root mean squared error, which is our outcome. So this model was kind of run, and it can be run on multiple times using different combination, but at least the first approach of the two features, which is temperature as well as the the temperature and the ambient pressure did not have an impact on the power output. Okay. Thank you.